Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how do you figure out the percentage of an element in an alloy. Okay, so let's get into this. So here we have a 0.155 gram of an alloy with aluminum and magnesium in the alloy. And we're told that it's dissolved in an excess amount of HCl. So what that means is that we have enough HCl such that all of the aluminum and all of the magnesium in the alloy dissolves and produces H2. So we're given the amount of H2 produced from this reaction. So we're going to use that to help us figure out how much of each of the substance is in the alloy, aluminum or magnesium. But in this case, they just want to know the percent magnesium in the alloy. Okay, so what do? So we need to, first of all, we need to write the reactions for aluminum with HCl and the magnesium with HCl. Since those are two different substances that are both reacting with HCl, we need to know how much of each is producing a certain amount of HCl. So since this is the total amount of HCl, this total amount comes from both the aluminum that is reacting with the HCl and the magnesium that's reacting with the HCl. Okay, so let's write out our equations. So we have aluminum, so we have aluminum metal, and that's going to react with HCl, and that's going to produce H2 gas. And this, since we have a aluminum metal reacting with HCl, this is going to be a single displacement or single replacement reaction where the aluminum is kicking off the hydrogen, and then you're going to get the chlorine gas left over. So you're going to have aluminum kicking off the kicking off the hydrogen. So we get the hydrogen left, and then we're going to get aluminum and chlorine compounds. So we're going to get aluminum chloride left over. So aluminum replaces hydrogen in the compound. So we're going to get aluminum Al and then Cl3. Since aluminum forms a 3 plus ion, so we'll need 3 chloride ions to balance the charge. And so we want to make sure we're balancing this reaction. So we have one aluminum, and we have one chlorine, but we have 3 chlorines here, so we want a 3 there. So we have 3 HCl, and now we have 3 hydrogens here, and we only have 2 hydrogens here. So if we want 3 hydrogens on this side, then we're going to need to have 1.5. So if we have 1.5, then we got to multiply everything by 2. So that'll be 2. This will be 6. And then this will be 3. And then this will be 2. So there's our balanced equation. So we have our balanced equation for the first reaction. And then we do the exact same thing for magnesium. So here we have magnesium metal. So this is solid, this is solid, this is aqueous. And that's going to react with HCl aqueous here. And then we're going to get, again, hydrogen gas, H2 gas, plus, and again, it's going to be a single replacement reaction. So the hydrogen gets kicked off to form H2 gas, and the magnesium is going to combine with the HCl. Magnesium has a 2 plus charge, so that means that this is going to be magnesium MgCl2, magnesium chloride. And now we're going to balance the equation. So we have 1 here, 1 there, 1 magnesium on both sides. That's balanced. We have 1 chlorine, 2 chlorine, so we need a 2 on this side. And so we have two hydrogens, so it's balanced. So now we have our two balanced equations. And so what do we do from here? Well, we're given the total amount of uh, the aluminum magnesium alloy. So that means the amount of aluminum plus the amount of magnesium total equals this. So we're going to need a system of equations. We're going to need two equations to solve this because we have two unknowns, the amount of magnesium and the amount of aluminum. So our first equation is going to be um, the amount of aluminum. So if we say, we're going to say aluminum is equal to X and magnesium is equal to Y. Let me double check to make sure that. So aluminum is X and magnesium is Y. So that this will be X will represent the mass of aluminum, Y will represent the mass of magnesium. So if we write that down, so aluminum, so the aluminum, the mass of aluminum plus the mass of magnesium is equal to this total here. So 0.155 grams total. So aluminum is X. So that means that X plus magnesium is Y. Y is equal to 0.155 grams. Okay, so here's our first equation. The mass of aluminum plus the mass of magnesium is equal to this total here. Great. Okay, so now the other thing they gave us is the total amount of H2 gas. So if we could figure out the amount of H2 gas that came from the magnesium, and the amount of H2 gas that came from the aluminum, those two amounts of each gas would add up to that, and we could get our second equation from that. So what we want to do is use our roadmap, right? So again, our roadmap is mass of A goes to moles of A using molar mass of A. And then we can go from moles of A to moles of B using the mole ratio between A and B. We're going to get this from our balanced equation. And then from moles of B to mass of B, again, this is in grams, going from mass of B. And again, we're going to use the molar mass of B to make that conversion. So all we need to do is set up our conversion factors using what we know, and we're going to have to use X and Y to do that to figure out the amount of hydrogen that was formed. So if we had the numbers, we could just take the amount of hydrogen gas, we could figure out how much hydrogen gas was formed and work backwards from the mass of our hydrogen gas to the mass of our metal. But since we have a mixture of metals, it's not going to be that easy. So we have to assume, what if we have an X amount of aluminum? We'll use that X amount of aluminum to then calculate and do our step-by-step calculations with our conversion factors to get to an X amount of H2 gas. So we're going to calculate the amount of H2 gas in terms of X, and then we're going to calculate the amount of H2 gas in terms of Y. And then those two amounts will add up to this total amount here. So let me show you and it'll become clear. So let's say we have an X amount of aluminum. So if we take that X amount of aluminum, so X amount of aluminum, this is grams. So we have X grams of aluminum. and we want to know how much gas was produced from that aluminum, how much H2 gas. So we want to go from mass of aluminum to mass of H2 gas. So we're going to follow our roadmap. So over 1, and in order to go from grams to moles, we need to use the molar mass of aluminum. So we looked that up in our periodic table. So the mass of aluminum is 26.982. So we're going to put 26.982 grams of aluminum over 1 mole of aluminum. So now grams of aluminum cancel out, and now we have moles of aluminum. So we want to get to grams of hydrogen. How much grams of hydrogen is formed from X number of grams? So we're going to have to multiply again by another conversion factor. So we're going to go from moles of aluminum to moles of H2 gas. So we're going to go to our balanced equation. So 2 moles to 3, so it's a 2 to 3 ratio. So 2 moles of aluminum on the bottom and 3 moles of H2 gas on top. So moles of aluminum cancel out. And then I have one more step. I want to convert that to grams. So I'm going to use the molar mass of H2. So since H2, that's going to be 2.0016 or 0.016. Yep, 2.016. So I'm going to have 1 mole of H2 on the bottom, and that 1 mole is equal to 2.016 grams of H2, and that's going to be equal to, and then now all I need to do is multiply and divide, keeping the X in there, and then I'll get the amount of X, the amount of hydrogen gas formed in terms of X. So when I multiply across the top and divide by the bottom, I get the following answer. So I get X, so X times 0.11207, 0.11207 as my answer. Let me double check. 11207. And so this is going to be grams of H2. So I started with X grams of aluminum, right? I don't know what the grams are, but we know it's X amount. And so I started with X amount and I converted that X amount into X grams of H2. So I've got grams of H2 in terms of X. Okay. And I can do the same thing for magnesium in terms of Y. So if I have Y grams of magnesium, I'm going to do the exact same thing. So I'm going to convert grams of magnesium to moles using the molar mass of magnesium, which is 24.305. So 24.305 grams of magnesium over or under 1 mole. Let me write that one better. 1 mole of magnesium. So grams of magnesium cancel out. And now I'm going to use the mole ratio to go from moles of magnesium to moles of H2. So I have 1 to 1. So it's a 1 to 1 ratio. So I have 1 mole of magnesium on the bottom and 1 mole of H2 on top. So moles of magnesium cancel out. And then I multiply by the molar mass of H2. Same thing here. So 1 mole of H2. And then on the top, 2.016 grams of H2. Moles of H2 cancel out. And now I do the exact same thing. I multiply Y across and I divide by what's on the bottom. And when I do that, I get Y times 0.082, 0.082, 945. So 945 grams of H2. So now I have the amount of H2 produced by aluminum in terms of X, and I have the amount of H2 produced in terms of Y for the magnesium. And so now I know that these two amounts of H2, this amount came from the aluminum, this amount came from the magnesium. These two added together should equal this total amount. So now I have my second equation. So let me write it here. So this is going to be, so 0.11207x. So I just put the x on the other side, plus 0.082945 y. I just put the y on the other side. And that's going to be equal to total amount of grams, 0.0163 grams of H2. So I have this equation, I have this equation, I have two equations, I have two unknowns. So now I can solve this. So all I need to do, we're interested in magnesium. So if we solve this for aluminum and plug it into this equation, so we'll solve it for X. So that means that X is equal to 0.155 grams minus Y. So we put Y on the other side. So now I can take this and plug it in for X into the other equation. So let's go ahead and do that. So that'll be 0.11207. And instead of X, I'm going to put this because Y is magnesium and we want it in terms of Y, so we could solve for Y and we'll know the amount of magnesium. So therefore, this is going to be 0.155 minus Y. And then so that's this part here. So then plus everything else, 0.082945y equals 0.0163 grams. Okay, so now I can multiply this out. If I multiply that out, I will get 0.017, 0.017 370, 370, okay, minus 0.11207y, and then plus 0.082945 y is equal to 0.0163 grams. So now I have this number and this number with y, so I can add these two together. If I add those two together, I get, give me a second. I'm going to get 0. Um, 0. Okay, give me a second. Okay, we'll have negative 0.029, so this will be negative 0.029125 y, and that's going to be equal to, if we subtract this from both sides, that's going to be ended up being a negative, what's that number? 0.0000107. Okay, and so now, and this is going to be grams. So now all I need to do is divide both sides by this number here. So this will be divide both sides by 0.029125. Divide this by negative 0.029125. So the negatives cancel out, become positive. This cancels out, and I end up getting y is equal to the answer 0.0367, 0.036738 grams. So 38 grams. That is the amount of Y, which for Y is magnesium. So we just found the mass of magnesium in our original sample. So now they're asking for what is the percent magnesium in the alloy. So to find the percent, remember percent is part divided by whole multiplied by 100 gives you the percentage. So this is our part. So the magnesium is part of the whole. So we take our part, 0.0363738 grams, divided by the whole, which is the original sample, the amount we started with. So that's going to be 0.155 grams. And then we're going to multiply that by 100, and we'll get our percent. And when you do that, you get 24.5%. So 24.5% magnesium. So that is the amount of magnesium in the original alloy. If you want to know the percent of aluminum, you would just take this percentage and subtract it from 100, and you'll have the percent of aluminum. So I hope this was helpful. I hope you enjoyed this video. If you like this video, please hit the like button. Put a comment in the comment section. Let me know what you think. And if you like my channel, please subscribe to my channel and help me out. And hit the notification bell so you can get notified for any other videos. And let me know if there's any videos you want me to do. I will be happy to do them. Thanks for joining me, and have a great day.